Welcome to this webinar. Are you anti-agile? Now, I've got to start with an admission, really. The prefix anti. When we think of it, most people think of the prefix anti meaning opposed to or against. Am I opposed to or against agile? Well, actually, in this particular case, what we're talking about is, am I the opposite of agile? Or we could argue, are we preventing agile? But for this one, we're going to go with, are you the opposite of agile in this case? I want to explain that. But before we get to that, I want to go through a couple of seemingly unrelated concepts. And I want to look at a new way of looking at software and a new way of looking at our processes and our methodologies. And this is something at Feabhas we've been really concentrating on for a couple of years now. We found a really good framework for approaching software. It allows us to look at questions like, why aren't software engineers any good at predicting timescales? And why are we not seeing agile technologies being adopted in the embedded world? Is it that we're just behind the curve? Is it that they aren't appropriate to us? What is it that's driving this? And is there a more appropriate method for it? I want to start with a really fascinating concept by a gentleman by the name of Philip Armour, there he is there, called the 5 Orders of Ignorance. Now, this was published as a paper back in the 1990s. Really interesting concept, and it starts with a really challenging question, and it's one that I always raise with my students. And that question is, what is software? And yes, people say it's opcodes, it's machine instructions that we program. Yes, it's sequences, selection, and iteration. Yes, it's functions and it's algorithms. But ultimately, software has a purpose. And where does that purpose come from? Well, you could argue it comes from the requirements. And what are the requirements trying to capture? They're trying to capture some customer need. We're trying to solve a customer problem ultimately. So software is a very interesting thing, that the software development process is about understanding the customer's problem, formulating a solution to it, and then codifying that in this strange mechanical language. So it turns out that software is a knowledge capture medium. It's a mechanism for capturing and codifying our understanding of the world. There's lots of ways we can capture understanding. We can capture it in books. We can capture it in our minds as well. Armour argues that actually our DNA ourselves is a knowledge capture mechanism. The problem with some of those is they are very long-term solutions. The real advantage of software as a knowledge capture medium is twofold. One, it's very easily and almost infinitely malleable. It's very easy to change. And secondly, it's made to execute. We can make it do stuff. We can actually give instructions that will change the outside world. Now, from a software development point of view, then, we're focusing on knowledge capture. So all development processes must be focused on the capture and then the codification of that knowledge. So we're true knowledge workers as software engineers. That raises a very important question. What do we do when we don't have all the knowledge? Well, this is where Philip Armour's 5 Orders of Ignorance comes in. He says the opposite of knowledge is ignorance, the lack of knowledge. And he lays out a framework for understanding different aspects of this knowledge and or lack of knowledge. So let's go through this framework very closely. He says there are 5 levels to this. We'll start at the bottom, level 0, which is a lack of ignorance. In other words, knowledge. Level 0 ignorance is codified knowledge that we can make execute. In other words, we can write software when we are at 0 order ignorance. At this point, I want to bring in that wonderful speech given by Donald Rumsfeld when he said, there are things that we know. These are the known knowns. Well, this works really, really well with the 5 orders of ignorance. So let's start with level 0 ignorance is the known knowns, the things we know. Level 1 is a lack of knowledge. These are questions that we don't currently have the answer to. Or as Donald Rumsfeld would say, these are the known unknowns. These are the things we know we don't know. Rather interestingly, when we talk to a lot of project managers, they believe this is what software is all about. They believe that there is a lack of knowledge. We need to ask the right questions, find the answers, and then code it into software. And that's all there is to software engineering. Oh, but it were that simple. The real killer for us is the next level up, second order ignorance. Second order ignorance is what you might call a lack of awareness. That is, you don't even know which questions to ask. Or as Rumsfeld would put it, these are the unknown unknowns. These are the things we don't know we don't know. The problem here is, of course, that's an unbounded set, and by definition, we can't possibly know what our unknown unknowns are. We might think of that as risk from a project perspective. We'll explore that again in just a second. Let's fill in levels 3 and 4. Level 3 is a lack of methodology. You don't have the tools or the methods for actually reducing your ignorance levels. That is, you have no mechanisms available to you to go from the things you don't know, to the things you don't know, and then capturing those as knowledge. We see this quite a lot in junior engineers straight out of school or college or university. When they're given their first project, quite often they'll sit there and they have no place to start. They have no way of knowing where to start working on a piece of engineering. They have no tools for finding out what their lack of awareness is. As we develop as engineers, we develop these tools, we develop these mechanisms, and they become part of our engineering toolkit. You can't really be a professional engineer without them. And level 4, just to finish off the set, is what Philip Armour calls meta-ignorance. That is, you don't know that there are orders of ignorance. Well, we can cross that one off right away. We now know that there are orders of ignorance. Let's come back to second order ignorance. This is really the big one from a process and a methodology point of view. We've just said it's an unbounded set. We can't possibly know what our unknown unknowns are, but we can take a guess. Here's a framework that we use. We say that second order ignorance, or risk to a project schedule, is inversely proportional to a number of factors. They are inversely proportional to, given a problem domain, the stability of that domain. That is, how quickly it changes, its maturity, how long it's been in existence, and probably more importantly, how much information is published on that domain, how complex it is, and what our experience in that domain of knowledge is. So let's take some examples. Let's take something that embedded engineers will be very familiar with. Let's take C programming. It's very stable. It only changes about once every 10 years. The ISO standard changes approximately every 10 years. It's been around since, well, 1968 now, but it's been a standard since 1990. There are dozens, if not hundreds, of books on C programming language. It is a relatively straightforward programming language. It follows very simple programming rules. And most embedded engineers will have years, if not decades, of experience in C programming. We sometimes say that knowledge has what we might call an atrophy curve. That is how long you can go while still retaining the knowledge of a particular domain. We sometimes I talk about the half-life of knowledge, and we say that the half-life of C programming is about 10 years. That is, if you haven't programmed in C for 10 years, after about 10 years, you've probably forgotten about 50% of what you knew. Yes. With UML, it's about 3 days. So we can say with some degree of confidence that in the realm of C programming, there are probably not too many unknown unknowns that we're going to come across. That is, we can estimate reasonably accurately based on our stability, maturity, complexity, experience. Let's go to the other end of the scale, another domain of knowledge, something like the Internet of Things. What's its stability? Well, it seems to be changing daily. It seems to defy definition. Ask a dozen engineers what they mean by the Internet of Things, you'll get 13 different answers. It's a very new technology, it's a very new concept, it's not been around for many years, and it has the potential to be extremely complex. What that means is there is a very high probability that there are many things we don't know about the Internet of Things as a problem domain. Therefore, all of our estimates are likely to be wildly off as a consequence. So this is how our second order ignorance estimating framework goes on. And this can happen across multiple different domains. So let's take some time and look at those domains. We'll look at them in a second. Another example of second order ignorance in action is what's known as the hype curve. When any new technology is introduced, you get this wonderful curve, which is the expectations or the visibility of the technology over time. As the technology is introduced, it becomes the next silver bullet. It's going to solve all the world's problems. That keeps increasing until we get to what is known as the peak of inflated expectations. There is the silver bullet there. Then we discover that actually it doesn't solve our problems, and we fall into the trough of disillusionment. This is a useless technology. Why did we even bother to adopt it? Over time, however, we suddenly realize that it's not a silver bullet, but it has benefits. We climb the slope of enlightenment. And eventually we reach a point where the technology is known, it is understood, and we know what it is useful for, the plateau of productivity. Now, I've shown it here as a measurement of time, but we could just as easily scratch out time and say, this is also a measure of decreasing second order ignorance. As we understand and reduce the number of unknown unknowns in this technology, we go through the hype curve. Until we get to a point where we understand all the questions, there are fewer and fewer unknown unknowns in this technology. Rather interestingly as well, this curve and the second order ignorance measurement also explains what is known as the Dunning-Kruger effect as well, which is the fact that people who have very little knowledge in a problem domain tend to overestimate their own abilities, whereas people who are highly skilled in the domain tend to underestimate their skills relative to their peers. Yes. The names on the graph change and get a lot cruder, it must be said. But again, we're talking about second order ignorance. When we look at this from a process point of view, then really, we're not talking about a set of rules, we're really talking about a set of methodologies. That is, tools that allow us to get from one level of ignorance to the next. So if we start at the bottom, we should have methodologies for accurately codifying knowledge. In the embedded world and in programming world, in the software world, those methodologies are quite often called coding standards. How to write code in a way that is unambiguous and doesn't leave mistakes in the code. We need methodologies for finding knowledge, that is moving from first order ignorance to zero order ignorance. And we also need methodologies for understanding and finding questions. And that's the more challenging set of methodologies. As we go up that graph, the skills get much more esoteric, much more abstract, but again, much more powerful. People that have strong methodologies for reducing second order ignorance are far more powerful as engineers. Let's switch topic for a moment. I want to talk about project domains. That is, the influences and drivers on any particular project. This work comes out of an extension of work by Michael Jackson. No, not the dead pop star Michael Jackson, the software author Michael Jackson. And we're going to look at this in a slightly simplified model, and I'm going to talk about three basic domains. Here's our first domain, the problem domain. The problem domain describes the world of the customer. This is the information, this is the business rules, this is the logic of our customer, the world that they live in and how it operates. This is how they perceive the world. Opposite that, we have the solution domain. That is the world of technologies, of engineering. This is the world that engineers typically inhabit. And I've shown these two worlds completely separate at the moment. So there is an adjoining domain here. It's generally called the interface domain. It is the overlap between the problem domain and the solution domain. That is, how does the customer's world interact with the technologies of the solution domain and vice versa? You might argue, and some people do, that actually that is the software functional specification. And that's a pretty good model in this case. As a requirements analyst, though, which is my background, I feel we have to consider all three domains as equally important. What I'm going to do as well is take the problem domain and solution domain, and I'm going to subdivide them. So we can look at the problem domain and split it into two. There are the problem domain requirements, and then there are the problem domain constraints. The problem domain requirements are the things that the customer would like to be true. That is, there is something in this world that the customer inhabits that they cannot do today, that they would like to be able to do tomorrow. There is also the problem domain constraints. These are things that are true in the customer's world, whether the customer likes it or not. These are the tacit rules of the customer's universe. Some people like to call these the everybody knows that requirements. When you talk to a customer, and they will give you a withering look saying, but surely everybody knows that. They define the rules of the market, the rules of the environment, the rules of the universe. In military terms, we used to call it concepts of operation. We can also split the solution domain as well. Let's split that into two. We have the solution domain requirements. In this case, the solution domain requirements describes the set of problems that the engineers have to solve. That is, the technical challenges that the engineers face. Some of them may be brand new challenges that we've never encountered before. Some of them may be well-known problems that we've encountered 100 times. We can also consider from the solution domain perspective the solution constraints. That is, things that are fixed in the technology world, whether we like it or not. So that could be pre-existing technologies, pre-existing customer relationships, skill sets, financing. All of these things are constraints that limit our particular solution to a problem. We'll revisit those in a bit because I want to tie this domain model with the idea of ignorance as well a bit later. But before we do that, I want to talk about a completely separate topic, but you'll see related, something called the Obeng project types. This was a framework developed by Eddie Obeng of the Henley Business School. And he says, as a project manager, as a business, we have to understand the type of project that we are working on because each different type of project has a different management strategy associated with it. More specifically, we have to apply our effort in different places and in different ways and spend our money differently depending on what our problems are. So he came up with 4 project types. Let's go through them. In the simplest and the best possible case, we have what Obeng called a painting by numbers project. In a painting by numbers project, the stakeholders, the customers, are absolutely sure about what needs to be done. It's possibly been done before. On the other side, the people implementing the project are very sure about how they're going to do this. Best practice has already been established. What we're saying here is this organization is going through some sort of repetitive project. It's done it before. It knows how to do it. It has the skills and technologies available. And furthermore, there are probably best practices, methodologies, and systems in place to repeat what we did before. We are fighting the same battle again. Moving up the scale, we have what Obeng calls movie projects. In this case, the implementers know how they're going to solve the project, but the stakeholders don't know what is actually to be done. Obeng calls these movie projects by analogy to the filmmaking industry. We know how to light sets, we know how to operate cameras, we know how to do special effects. The one thing we don't know is what the script is. We don't know what the story is. So we have the expertise, but we have to spend our time and effort here defining what it is exactly we want to achieve. Third one is what Obeng calls a quest project. This is almost the exact opposite. The stakeholders know very clearly what is to be done, but the implementers are not sure how they're going to do it. The example that Obeng gives and others give, and I love this example, is cure cancer. It's very easy to specify that system. Nobody will die of cancer, but that gives you no clue as to how we're going to do it. All of the effort here needs to be spent in defining how we're going to do it. In this particular case, the implementation is likely to be extremely novel and extremely unknown. And in the worst possible case, we have what Obeng calls a lost in the fog project. That is, stakeholders aren't quite sure what needs to be done, and the implementers aren't quite sure how it's going to be doing it. Basically, we're attempting to do something that nobody has done before. Now, if you've been tracking along with this Obeng project and the solution domain and problem domain, you can see there's a sort of an overlap between the two. So we can map the Obeng project types onto solution domain and also onto problem domain second order ignorance. So let's do that. Here are our problem domain and solution domain. In our problem domain, we could have potentially very high levels of unknown unknowns. There are lots of things we don't know about the problem domain. Also, we could have a very low second order ignorance. The problem domain could be very well known to us. Let's use the term ignorance here for that. We are ignorant or not ignorant or knowledgeable about the problem domain, the customer's world. Similarly, we have the same framework on the solution domain. We could have lots of unknown unknowns in the solution domain. We could have very well-known and well-understood technologies. Let's use the term innovation for that. We have innovative technologies. We have well-developed, well-known technologies. We can now think about mapping the Obeng project types. So let's do that. The most simple project, the simplest mechanistic project we can have is where we have a well-known understanding of the problem and we have well-known and well-understood technologies. A really good example of this is something like the build your own website companies, Wix and GoDaddy and companies like that. In such systems, all that is required is for you to specify what your domain name is, what the text is going to be, what graphics you want, what colors you want, and the solution domain is so well understood, it can be so proceduralized, it can actually be automated. A big handle is turned and out comes your website. So the problem is well understood, the solution technologies are well understood. We have a painting by numbers project. It's a repeatable mechanistic project. In most cases, however, software projects don't fall into that framework. When we start to look at agile projects, their roots are really in the world of high ignorance in the problem domain and low innovation in the solution domain. If we look back to the Agile Manifesto and some of the original methodologies of Agile projects, we're saying, let's have technologies like user stories. Let's have customer representatives as part of the team. Let's have Scrum product managers. All of these are about making sure that we have got someone from the customer's world, from the problem domain, who we can ask and say, what should happen next? What should happen here? What tacit information am I missing? So they are all methodologies for reducing the ignorance of the problem domain. However, in the classical Agile project, the solution domains are tacitly given as being well known and well understood. They are web technologies, they are Java, they are Linux servers, they are enterprise Java bins, whatever they happen to be. These technologies are well known and well understood. And a lot of agile methodologies actually rely on this. They say, we will rely on best practice. We will rely on design patterns. There is a benefit to doing these things. We will use best practice in all cases. We can only use best practice if we understand the solution technologies and know what best practices are. Of course, this is an Obeng movie project. However, in the embedded world, we quite often have the exact opposite of that. And this is where the title of this presentation comes from. When we say, are you anti-agile? I don't mean, are you opposed to agile? I'm saying, are our design drivers, are our project drivers opposite to what they would be to a typical agile project? That is, do we have a well understood problem domain, but our solution domain has very high innovation in it? In many projects, the solution domain is actually very well known and very trivial. One of our customers in the past, they made electric showers. It is not really a challenge to understand the problem domain of electric showers. Similarly, let's take a company like Dyson producing vacuum cleaners. The problem of cleaning floors is well known and well understood for the most part. There may be questions that we need to ask, but there are very few unknown unknowns in that. However, in the solution domain, James Dyson used a completely new technology to solve a common problem. So we may have very high innovation in the solution domain. In this case, having a customer representative on site or writing user stories is not going to help us. No amount of requirements analysis is going to give us a solution. We need different methodologies. We need prototyping. We need research and development. We need to explore solution ideas. We need to try new technologies. This also falls into the realms of same but better projects, as we might call them. The customer comes to you and says, we really like the product you sell. We want it to do exactly the same, but better. There is only a stepwise improvement you can do to a certain extent on the technologies you've got before you suddenly have to stop and go, we have to come up with a new way to do this. And now we have to investigate new and innovative technologies. So for many embedded projects, our world is we understand the problem, we don't understand the solution domain. Of course, these are our quest projects. And then finally, we get the Obeng lost in the fog projects. Now, Niall Cooling of Feabhas calls these walking in the fog projects. I really like that term. In this situation, the customer has some vague unease that there is something wrong in his world, but they can't necessarily articulate it. And we have no idea of what technologies are available to solve that problem. Now, Obeng calls these lost in the fog projects. We call them walking in the fog projects because walking in the fog is a very easy way to get very lost and irretrievably lost. But if you have someone with a map and a compass, if you have someone with a vision, then you can actually move in an area that other people can't get to. These lost in the fog projects are where breakthrough technologies can occur. This is where step changes in our understanding and step changes in our market can take place. So there is merit in these. So if you have strong leadership and leadership with a strong vision, these can be really, really powerful projects. However, if you are working with weak leadership, then they are a great way to get completely lost and pour money down the drain. So we need to be aware of these things. So here's a framework then, putting the Obeng project types onto Armour's second order ignorance model. And it maps up very closely. There's one problem with this framework. It is basically purely analytical. You can identify a project, but it doesn't give you any framework of where to go next. And this is where frameworks like Cynefin come in. Cynefin was a project framework developed by Dave Snowden in the late 1990s from his work at IBM Global Services. And it tries to encompass this idea of second order ignorance and project types, but also to give some framework as to how to move forward, some framework for actually making progress, some framework for methodologies. Now, in the Cynefin framework, there are 4 panels. Originally, there were 3. On the right-hand side of the framework, we have what Snowden called the simple projects. That's split into 2. Simple projects can be obviously simple or complicatedly simple. Sorry, excuse the oxymoron there. On the other side, we have complex and then chaotic products. So let's go through these each in turn. Let's start down in the bottom right-hand corner with obvious projects. With an obvious project, it is well known the relationship between cause and effect. This is a well-known thing. All we need to do is work out what this particular problem is, categorize it, and then apply the best practice for that particular problem domain. Really, we're talking about projects where the solution domain and the problem domain are full of known knowns. There are very few unknown unknowns in there, a very low second order ignorance project. Moving on, a complicated project takes this idea and says, in some cases, it is not obvious the relationship between cause and effect. It requires either strong analysis or it requires expertise. There may be multiple ways of solving this problem. In this particular case, we need to apply a different methodology. We need to analyze the environment, sense the environment, find out what the facts are, work out what the best practices could be, and then pick one. So we're not in the realms of best practice, we're in the realms of good practice. There may not always be right answers for everything. We could argue that in this particular case, we're in the realms of very low second order ignorance in the problem domain and the solution domain, but more so than the previous one. Complex projects change though. In a complex project, there is no way to look at it and understand what the solution will be. No amount of expertise can help. Very commonly, this practice has never been done before. There are no necessary right answers. So what do we do in this case? Well, the Cynefin framework says we have to probe the domain. In other words, we have to perform experiments. Snowden recommends performing what he calls fail-safe experiments, experiments that can fail without killing the project. Now, if we perform an experiment and it gives a successful result, we do more of that. We amplify successful experiments. However, if our experiment yields 2 negative results, we do less of that. The idea is for us to try and find out where the good practices may or may not lie. That's where we do the sensing, and then we establish how to deal with those. So we might consider those as emergent practices. One could argue that this is the realm of agile projects. We don't know when we start an agile project whether the situation is well known, it is obvious. So we explore it, we try things. If they don't work, we reorganize. Self-organizing teams, project wash-up meetings, project post-mortems, sprint post-mortems. They are all about finding out what works. Next up, we have chaotic projects. That is, there is no obvious relationship between cause and effect. We are potentially out of control. In such projects, what we have to do is act very quickly to establish order, get some stability in the project, find out where that stability is, and then attempt to turn that chaotic project into a complex project. Once we have a complex project, it is more or less under control, then we can start to experiment and find out what works and what doesn't. In the realms of chaotic practices, really, we've never done this before. Nobody's done this before. There is no way of knowing what the best way to do things is. We are growing it as we go along. We are very much in the realms of unknown unknowns. This is lost in the fog projects. And then right in the center, we have what Cynefin calls disorder. We don't know where we are. We could argue that that is perhaps lost in the fog. But in this case, we're really in the realms of meta-ignorance. The big problem with being here is if we have no framework of knowing where we are, people will tend to resort back to their comfort zone. So people who are familiar with working in obvious problem domains, where there are best practices and rules, will naturally try and arrive and apply best practices, rules, processes, and procedures. The problem with that is it is very, very easy to tip over from obvious into chaotic and drop out of control. And simply applying more of your comfort zone tends to make things worse. We've all seen companies where the processes aren't working because they don't match the project types that we've got, and applying more process just doesn't work. Certainly, I worked in one company which was like this, and I said, let's try something different. Every time we ever tried to apply the company's processes, they have always failed. Let's try something different. Let's find a new way of doing things. The worst that can happen is we are no worse off than failure. To which the response was, no, we'll try the process again. You never know, this time it might just work. And that's the reaction of people that are in disorder. Ideally, what we're seeing here is this drift over time as chaotic programs and chaotic systems, they become practice, they become complex, we start to develop processes, we start to work out how to deal with them, they then become complicated projects where experts can actually analyze them, and eventually things that were originally chaotic can become well known and obvious. And there's a drift over time from complete chaos into things that are well known and established technologies. And we could argue that potentially any new technology will go through this drift over time as we learn. I'll leave you as an exercise of the reader to think about how this could happen with the Internet of Things, for example. So what do we take away from all of this then? First of all, software is not an engineering practice like mechanical engineering or electronics. It is a knowledge capture exercise. What we are doing is understanding the customer's domain and capturing it in a very particular format, in a codified format. That's what we're doing as software. That's why we have to have different methodologies and different processes to mechanical engineers and electronics engineers. In any particular project, the unknown unknowns, the second order ignorance, is a critical factor. Understanding where your unknown unknowns are in your project is a key part of project management. They highlight where your risks are. If you don't know where your unknown unknowns are, you can't make any judgments about the project at all. And every domain and every company will have its own levels of unknown unknowns. They could be in the customer requirements domain. They could be in the customer's operational view of the world. They could be in the solution domain technologies. They may even be in the solution domain constraints. We really don't know what we don't know about the solution domain restraints. We need to understand where our unknown unknowns are and apply them. And it's worth noting that in our experience, embedded systems often have fundamentally different drivers. That is, their unknown unknowns are in a fundamentally different domain to the classical agile projects, which means there is no one-size-fits-all methodology. And actually, people that say, if you don't apply agile as I understand it, you are clearly wrong, clearly haven't understood that actually they are taking on board some tacit information, some tacit information that is missing from their world, that is not the same in our world, in the embedded world.